Hey, how's it going guys? My name's Daniel, aka HashLips, and today we're going to learn how to reveal NFTs. So, welcome back to the channel, and I hope everyone had a great weekend. In today's video, I'm quickly going to show you how to take your NFT smart contract and simply add a reveal function for those of you who want to actually have some image that shows up that doesn't truly show the correct NFT and metadata, and then once it comes to the time to reveal these NFTs, you can simply do that. Anyway, let's jump right in and see how we can achieve this. Before we jump in, I really want to thank the 6,500 subscribers that's following this channel, and thank you so much for your comments and love. I really appreciate that. Next, I want to say that a prerequisite for this video would be that you actually go and watch the Solidity basics if you don't understand what I'm talking about. This is a great course that will teach you the basics of Solidity and anything we do in the future. Then, I also highly recommend watching this upload 10,000 NFTs to IPFS just to learn more about metadata. But if you already understand the concept of metadata and why we have to return it from a smart contract, then you're good to go and you can just keep on watching this video. So first off, go to the repo HashLips/Solidity smart contract. This repo will always be updated whenever I create smart contracts and make videos about them. This is a great way for you guys to actually find the source code and try it out yourself. If you go to the contract and the NFT folder over there, you can see that there's already two files in it, an nft.sol and an nft_full. The nft.sol we used in a previous video, and that's why it's here. The NFT full is something that will always be updated. It's something that if I find a method or some feature useful that we create, I'll add it to the nft_full for you to have the full NFT package that we are going to create, and you can go and test it. Right. Today we are looking at adding a reveal function. So I'm going to start off with the nft.sol. So what you can do is click on this. We're going to start off with this as our base and adapt it, add new features, and we also have to update the withdraw method. Let's get going. What you want to do is scroll all the way down, and from this last curly brace all the way up here to the comment, copy this, and then head over to Remix. Remix is a great tool and Solidity compiler. You can check it out on my previous videos. But all you need to do now is go to remix.ethereum.org and go to this contracts folder, right click and say new. We are going to create an nft_reveal.sol. After we have created this, you'll see Remix import all these dependencies, so you can just close the artifacts. Make sure that you are on the nft_reveal. Then I'm going to paste what we've just copied. Remix should start doing some stuff, and you'll see that it imports dependencies and all these things, and eventually you should see this green check mark here under the compiler section. If you do not see a green check mark, please make sure that you've copied the contents correctly. Let's head back to our nft_reveal file. So let's get going and start coding the feature for our reveal. It's very simple, and please, like I said, look at the previous videos if you don't understand the code that's here already. But if you do, all you need to do is append the following methods and variables. Let's go and create a new variable underneath the paused variable over there. We're also going to make this a bool, and this could be potentially public, but after making it public, we need to give it an intuitive name. I think an intuitive name for something that will be revealed is actually revealed, right? Now we can have this revealed boolean be false in the beginning, and this would set the tone for the smart contract. We basically want to alter this function or alter this variable with a function in some way to make it true, and only once it's true, it's going to give back to us the true metadata. So add a boolean over there, make it false, and call it revealed. Then next what you want to do is let's actually go and create the function that will update our reveal. So I'm gonna, after this only owners call, because only the owner will be able to call this, create a function. We create a function by typing the function keyword, and let's give this a name. I actually am going to call this function reveal, which is a smart name to call it, I guess. And the reveal function is not going to take any arguments. It is going to be public, and it is going to be only for the owner. And this is our only owner modifier. I'm going to open the curly braces, and then here we just need to update the reveal variable. So we're going to say revealed is now going to be equal to true. Okay. It is advisable that we only create a function that will turn reveal to true once. We shouldn't create a function that can revert this. We shouldn't create a function that says hide. And the reason for that is because people don't want you to hide the NFTs whenever you want to, willy-nilly. We want people to trust your NFT and actually know that once it's revealed, it stays revealed. And that's why I'm only making one function. The next and final step that we actually have to do is go all the way up where we return the token URI. Now we have a token URI function, and let's read through it to fully understand it first. Token URI takes in a token ID, aka 12345, whatever the ID of the token or the NFT is. It is public, view, and virtual. Virtual is just so that we could overwrite it. So this token URI actually comes from an underlying library that we inherit from. All right, so that's why it is overridden. So don't worry too much about these, but what we do need to pay attention to is the return. We see that this method returns to us a string, and that string is actually the path to the metadata. Metadata looks something like this. It has sometimes a name, description, image, an external link, and we can also add cool things like attributes, like you've seen before in my tutorials. This is just a simple metadata example which I will be using here. And then we also have more complex metadatas which will be returned once we actually have an NFT to show to the user. That metadata looks something like this. So if I go to the Nerdy Coder clones, this is just my own website, so don't pay too much attention, rather pay more attention to how the metadata looks. You can see that this metadata is much more structured and there's more going on, and it's actually showing the information of this particular NFT. We want to hide this data from the user at first. When the contract is not revealed or the NFTs are not revealed, we want to hide it by actually returning this metadata. Why do we want to do that? Because if the program receives this metadata and looks at the image, so if I click on the image quickly, we can see that it's just a plain card, and I've put the lips on there, but it's basically a hidden card. If we go to the other metadata of the Nerdy Coder clones and I click on it, it actually shows the NFT. And that is exactly why we want this metadata to be hidden first. So we're going to show this one, this to the user. It's going to be the hidden one, and then we're going to only reveal the metadata that's needed, and we want to show after the review variable, the boolean, is ticked to true. All right. But this function returns to us this metadata URI. So it returns to us this top part over there. Okay, so let's go back and see what's happening next. We have a require statement, and this require statement, if you looked at the previous Solidity basic tutorials, it's basically a validation check to see if this token exists. If it passes it, it's cool. Then we grab the current URI from the base URI, the current base URI, meaning that we've set the base right in the beginning when we initialize the contract, and we can also update the base, but it saves it in memory in this function. And then it returns. So it returns either if there is something. So if this, for instance, has actual data in it, Then it says, cool, if it does have data, return to us this string, and this string would look something like this at the top here, or this. So return to us this string, otherwise just return an empty string. Okay. We need to kind of intercept this in some way to say, well, you can only return that if this is not revealed yet, right? So let's go ahead and put in a if conditional over here. Firstly, we can write an if statement and then open our curly braces. In this if statement, this will be the place that it's going to look in first, and if it does, it's going to return a different string and end the function. So let's look at what would work great in this if statement. We need a conditional, and before we created this revealed boolean, I'm going to type in revealed over there. This is the boolean here right at the top that we've created, and I see there is that comma shouldn't be there, but over there is the revealed boolean, and it's false. So if we go down to our if statement, we can say that if our revealed is still false, so put double equal sign and then false. This statement says that if this contract is still false, if it's not revealed yet, then execute the following in these curly braces. And the simplest thing that we can execute here is a return statement. If you execute a return statement before another return, it will return from the function over here, and it will not consider the rest of the function code, which is perfect for our use case. Let's first create a variable that we want to be returned, right? So we can say that we want another string. This string is also going to be public because I would like to see the variables that I use, but you don't have to make it public. But anyway, this is going to be called not revealed URI, like that. And we are not going to initialize it over there. We're not going to give it a value because we will be initializing it right after this URI. So after you have initialized the base URI, I think it is a good practice to maybe initialize this as well in the constructor, our not revealed URI. So we have to make it memory. Memory is the keyword, remember, for variables that only live for a brief second. So I'm going to say that this is the not revealed URI. Also append a init in front of it, just so I can keep to the convention. And there we go. Now we have something that we can work with. Now, in my case, and I think in most cases, when you deploy a smart contract, there's really no need to actually change this not revealed URI. But for best practices, I actually want to implement a function so that we can update it later. Much the same like the set base URI function. We can actually go down to the set base URI, which is the base URI, and duplicate this. I'm going to duplicate this function, and then I'm going to simply rename its name. So there's the two functions over there and over there. And this one I'm going to say this is not set base URI, but set not revealed. So this is the set not revealed URI. This is simply for if you have made a mistake in your code, and sometimes you do make mistakes. So just make sure that you implement this just for safety's sake. So we are going to say that we want to set this not revealed URI, and here we have to actually set the this variable here at the top. So I'm going to go down, and I'm going to say we want to set this to the new not revealed URI. Okay, this will be perfect, and it's only called by the owner, so no one can mess around with this. It's only if the owner wanted to update this for some reason. Let's go up and execute this as well. So I'm going to just duplicate this function because we have to call it in the constructor. So after we have set the base, we can go ahead and set this not revealed URI too. Perfect. And now we can actually go down to our if statement. over there, and we can say, so if the contract is still not revealed yet, we want to return. Let's return the string, which is the not revealed URI. And because that's a string already, we don't have to typecast it into a string. It is already a type of string, so we know it is. And we're just going to simply return that fully qualified URI. This should technically work, but as always, we have to test our smart contracts, so let's go ahead and do that. In order for us to test our smart contract, we can go now to our deploy section over here. We can clear out any previous deployments that we've done. Make sure we're on a JavaScript virtual machine. Anyone will do. And then just make sure that you are selecting the NFT reveal contract. We don't have to pass any ether in here, so we can make that 0. Next, in this deployment fields, you'll see that we have to pass in a few parameters, and now we're going to do it properly. So let's say our name was, let's make up a name. We're gonna call these the WOW NFTs, right? And our symbol might be something like WOW NTS. How about that? WOW NTS. All right. Then for our base URI, I'm going to return our base URI as being this part of the actual URI that I want the proper data from on a later stage. So if I go to Remix, I can go and paste that in there. Then I want my URI that's going to be shown to the user if it's not revealed yet. Well, I can go back to, which one would that be? It's this one. This time I'm copying the fully qualified URI that I need to display to the user. Keep in mind, I'm keeping the .json appended because the contract won't actually do that itself. So if you also are running a server, you don't have to append this if your server is returning your JSON, but I'm doing it like this. So I'm copying everything and I'm putting it here into the not revealed URI. Let's go ahead and deploy this contract. So now let's go ahead and click transact. Once we do this, you can see that it built successfully over there. And here is our smart contract. We can open the smart contract and see all its nice features, methods, and also now these extra parameters that we've set. So we have the not revealed URI, which looks something like this. We also have the base URI, which should look like something like this. But we care about the token URI function, because if we call token URI function, which is this one, theoretically, it shouldn't actually return our not revealed one, right? One that should not be revealed, this one. So it shouldn't return to us the nerdy coder clones because the contract is not revealed yet. How do we know that? Is because we made this property revealed, which is now currently false. So let's go and test that out. If we go down to where the token URI function is and we expand it so we can have a better view, let's go and add just token ID 1. Please make sure that there's actually some tokens. By clicking on the total supply, you'll see that there is actually 20 tokens in the smart contract before you go and execute token URI. So you can see that if I now am querying token ID 1 and I call it, here it's returning to me this URI, and that is perfect. If I go and search for this, I know that I'm going to get this base metadata because the contract is not revealed yet. And now simply, if I want to change this revealed into true, meaning after everyone has purchased the NFTs, I can simply go to the contract, whether it's here on Etherscan, doesn't matter where it is, and click on reveal. This will be a one-time function. You can click it again and again, but it won't matter. It will only ever set the Boolean revealed to true. Let's go and verify that by clicking again on revealed over there. And yes, it's now true. But the true question is, if we're going to call token URI now, is it going to update? Let's go and call it. And indeed it did. Now that I click on the call function on token URI, meaning that OpenSea will now actually be able to get this URI back. So if I copy and paste it in there, we will actually see that we get the proper metadata, and OpenSea will actually show the image of your revealed NFT. Guys, I hope that you enjoyed coding this with me and that you can now go and use and reuse this contract in your own project. Please be aware that these are tutorial coded contracts, and please read through them carefully so that you can make your own decisions if the code is fine. All right. One last thing I want to mention before I exit this tutorial is just the payment method. What do I mean by the payment method? Well, a lot of people have asked me, how do you actually withdraw your money from the smart contract? Or why is my money not coming to my address when someone buys NFTs? Well, guys, it's simple. The contract won't simply transfer it to your address. You have to go on the contract. There is a withdraw function called withdraw. If you click it and you are the owner, you can see this method here right at the bottom of the smart contract. It would simply go and take the sender's address, which should be the owner, and send this balance of the actual contract, all the balance, the whole balance, to that address. And that's how you actually get the money out. But there's something I want to mention about this send function. You have three ways of actually transferring Ether in a smart contract. I'm quickly going to show you those three ways, and then I'm going to show you which way we should use, and I'm going to update this contract as well as the full NFT with this contract. So let me quickly show you that. So the three different ways of actually sending Ether is you get transfer, send, and call. So let me go and do a transfer. If I say payable, which I need a payable address, and I use the message.sender, please watch the Ethereum basics tutorial that I have if you don't understand the message.sender object. And I go transfer, like so. I can specify a value in transfer, and it will actually transfer that value. This value is usually in way. But transfer has now recently been deemed as something that you should not be using. And the reason for that is that transfer only sends to this transfer object, along with the transfer object, 2,300 gas, which is sometimes, and not always, but which could be sometimes not enough to perform the action where it's transferring it to. Let's say that you were transferring Ether not to an address, but to another contract. That contract will sometimes not have enough gas to perform the action, which makes this transfer function actually not great. The next payment method is send, and you do it like this. You don't need a require statement around send, but keep in mind that send returns a success or not. So you have to at least go and capture it. So we can say if this was successful, then go and put it into the successful Boolean and then do something with the success. So we can say require down here. So we can say require that this transaction was successful. And that's how you use the send. It works exactly the same. It is payable, send, and then a balance. All right. And this is how you then cast that return value into a Boolean, and we validate it with require. That's why when you see this written, you'll actually see that it just puts a require, wraps it around a require, seeing that it's already a Boolean, right? So you can simply do that with a send. The last payment method, and the one that I'm going to be using from now on, is actually called call. So how do we use call? Well, we can say payable, and then we also have our message dot sender. Then we say call. Now call is a low level function, and the nice thing about call and why people actually recommend it is because it actually transfers the remaining gas that was sent to this contract to the next destination. Meaning that call will allow you to actually complete all the transactions that the contract needs to perform. in other contracts too. And that's why call is my preferred way and the preferred way that the documentation tells us to use. How you would use call is you put your curly braces inside, and all you need to do is you need to specify a value field. Now this value field, in this case, we are going to make this address, which is this, dot balance. And we can also do it here at the top if we wanted to in the transfer. Anyways, but after you have called that, what you need to do is actually append empty brackets, sending this empty string along. Once you have that, payable also, well, this payable function of call also returns now a boolean, but it actually returns two things. It returns a boolean and a data integer, I believe, but we only want to use the one. I just want to see what this is moaning about, and it's saying that we don't need that extra bracket. All right. How we can handle this is much the same way how we do the require here, but this returns two variables. So we actually have to, in this case, do the first way. We have to take the boolean, which I will be calling success, and casting it. But this is not going to work because this function returns two booleans, or two values, not two booleans. So I have to actually put this in brackets and then omit the next one like this. If you do it like this, you actually cast the first return statement into the success, and then once that happened, you can actually go and do the rest. We also need to remove this bracket here at the top of the balance, because we probably don't need that. Yeah. Now we actually need to use this. So it's saying that it's expecting a bracket Y. Let's see. So we have payment, so payable, which is our address. We use the call. Then, okay, we don't need this bracket for call. And then we don't need this bracket at the end. All right. But this will still give us a warning, because how I explained to you earlier is we need to use this and we need to check if it was actually a successful. How you can do that is by using require and then going and passing in the success boolean over there. Now, that's how you would do a perfect transfer to a contract. And we can go and test this out. Let's discard of these two methods now and use the proper one. I'm going to leave this in the future contracts because I want you guys to get used to using the most updated way of doing things. But let's go and test it out. Let's say we had our contract here on the left. We need to redeploy it because this logic we just changed. So let's go and select our NFT reveal contract. Let's open the deploy section. Let's just do a bunch of tests because we don't need to really test anything else. I'm going to do a transaction so we can actually get a smart contract down here, and it is successful. We need to actually now send some ether to this contract. I'm going to do that by simply switching to another contract and using the contract as if I was a guy or a girl who wanted to buy an NFT. All right. So I'm going to send a bunch of ether. I'm going to send 10 ether actually. Let's send 10 ether. We go to the mint function. I'm going to send by about 4 NFTs. I'm not really taking in consideration how much an NFT costs. I'm just going to send 10 ether. I'm going to paste the address that I want to mint these to. When I say transact, this actually minted the 4 NFTs. And it took my 10 ether. You can see that this contract address now has 89 ether. Let's swap back to the owner because we want to withdraw everything from this contract after everyone has purchased. Take a look and notice that the owner now has 99.9 ether. And if I go down and say withdraw and I go up, you can see that there's now 109 ether. Meaning that 10 ether was transferred to me, the owner. And that's how you use the the withdraw method and actually properly transfer ether to contracts and to addresses. I really hope you guys enjoyed this video with me tonight, and I just want to mention something. If you go now to the HashLips.online website, we have started finally a Discord channel. Please go and check out the Discord channel along with the Telegram channel. So you can either go to Discord or Telegram over there, and then you can go and join one. Our community is growing very, very fast. But the reason why I decided to make the Discord channel is for more interactivity for me to have with you guys. If you go into the Discord channel, we will have regular voice chats over here, and it's also separated into nice channels over here on the left hand side, where you get dev chats, developer job chats, developer shills, and developer ideas. You can already see people have started chatting around. I want everyone to go actually and join the Discord channel, because this is very good, and in the future you will find me on here actually giving advice, and you get to meet a bunch of new developers. Once again, thank you so much guys, and have an amazing night.